All right, so what we're going to be working on today is we're going to be looking at graphing the tangent of x. So y equals the tangent of x. And one of the things, so when we write y equals the tangent of x, what we're saying is that y equals the sine of x over the cosine of x. So whenever the cosine of x equals 0, that means we're going to have an asymptote. So I draw my graph. And I'm going to have pi, negative 2 pi, pi, and 2 pi. So if I say here's 1 and here's negative 1, I'm going to have 1, 0, negative 1, 0, 1, 0, negative 1, 0, and 1 is my points. So I'm going to draw my cosine curve. So there's my cosine curve. So whenever this curve hits 0, I'm going to have an asymptote. And the reason that I am drawing this is just so we can see where the asymptotes are going to lie. So we have an asymptote. So when we graph the tangent curve, we're going to have what we're going to do is we're going to have asymptotes at negative pi over 2 and pi over 2. That's going to be the main area that we are concerned with. We'll also have one at negative 3 pi over 2, and we'll also have an asymptote at 3 pi over 2. So we're going to draw our asymptotes. Now the shape of the tangent curve, so the shape of the y equals tangent of x, is going to be, we are going to come up and we're going to have this shape. And then when we come up from 2 pi, we're going to come up, actually we're going to come up like this. And then over here from 3 pi to 2 pi is where we're going to do that shape. So this is the general curve for the tangent. And when we look at the cotangent of x, we're looking at the cosine of x over the sine of x. So when we see sine of x equals 0, here we're going to have an asymptote. So we're going to draw our cosine curve. And we're going to have negative pi, negative 2 pi, pi, and 2 pi. So we're going to have 0, we're going to call that 1, and this negative 1. So we have 0, 1, 0, negative 1, 0, 1, 0, negative 1, and 0. So we're going to go ahead and draw. And then wherever sine hits, that's where we're going to have our asymptotes. So when sine hits 0, that's going to be our asymptotes. We cannot have, we're going to have an undefined cotangent there. So if I do y equals cotangent of x, I'm going to have I'm going to draw my graph. And I'm going to have 1, -1. And then at negative pi, negative 2 pi, I'm going to draw my asymptotes. And asymptotes are dashed. And then the same at pi and 2 pi. I'm going to draw dashed lines here to show my asymptotes. Now, as tangent had this curve, cotangent is going to do this. So cotangent is going to be the opposite of the tangent curve. So if we look at the equation, the general equation of y equals tangent of bx, and our general form is going to be y equals the tangent of 2x. And what we're going to see here is that we're going to say that for tangent, because our asymptotes come at negative pi over 2 and pi over 2, that we're going to say bx equals pi over 2 and bx equals pi over 2 and negative pi over 2. So then I'm going to say 2x equals negative pi over 2. And when I solve for x, I'm going to divide both sides by x. So I get x equals negative pi over 4. And I'm going to have 2x equals pi over 2. So I divide by 2, and I get x equals pi over 4. So now when I get ready to graph this, I'm going to draw my graph. And what I'm going to say is that I'm going to have pi over 4 here, and I'm going to have negative pi over 4 here. Now, my amplitude for tangent for this equation is 1. So I'm going to have 1 and 1. So what I'm going to see for the tangent is that I'm going to have my asymptotes at pi over 4 and at negative pi over 4. So with my asymptotes, that means that at my middle point, I'm going to hit my amplitude. So when I graph this, I'm going to come through something like this for my graph. So halfway between pi over 4 and 0 is pi over 8 and negative pi over 8. So at pi over 8 and negative pi over 8, I need to have a point that is at my amplitude, and that's where I'm going to meet, my lines, my curves have to go through those points. So this is example 3. This is what the tangent of bx looks like. So now what we're going to do is we're going to look at example 4, which is y equals a tangent of bx. So our general equation we've got, now we're going to look at a specific equation. So we've got negative 3 times the tangent of 1/2 x. So the first thing I need to do is I need to figure out where my asymptotes are going to be. So I do 1/2 x equals negative pi over 2 and 1/2 x equals pi over 2. So then I'm going to, in order to do this, I'm going to have to multiply everything by 2. So I get x equals negative pi, and I'm going to multiply by 2 here, so I get x equals pi. So I'm going to graph this. So what we're going to have is we're going to have negative pi, and we're going to have pi. So at negative pi over 2 and pi over 2 is where we're going to have to hit our amplitude. And because this is negative, we're going to have to flip where our points go, because we have an amplitude of 3, but it's negative. So we're still going to have our asymptotes where they're drawn, where they would normally be drawn, but we're going to come through, and our curve is going to look more like a cotangent curve. So the negative amplitude makes a tangent look more like a cotangent. And now we're going to look at example 5. And example 5 is y equals a cotangent of bx. And our equation we're going to use, our specific equation, is 1/2 cotangent of 2x. So, if you remember from our original graph that we did, we said that cosine goes between pi and 0. Okay, so when we're looking at this, we're going from 0 to pi. So we're going to decide, one, where our asymptotes are going to be. So we're going to say that 2x equals 0 and 2x equals pi. So I'm going to divide by 2, and I get x equals 0, and I'm going to divide by 2 here, I get x equals pi over 2. So now I'm going to draw my graph. And so I'm going to have pi over 2 for one of my asymptotes. And I'm going to have 0 for one of my asymptotes. Now, remember, cotangent looks like this. It looks like the negative of the sign. And so what we're going to have to do is because we're going to say that this is 1, this is -1. So we have 1/2. So we're going to divide this into 4 areas. So we got pi over 4. That's going to be where we hit 0. So we're going to hit 1/2 there like that at pi over 8 and 3 pi over 8. And then I'm going to draw my cotangent curve. So this is what we're going to look like. So in this video, what we've gone over is we've looked at what y tangent of x looks like. We've looked at what y equals the cotangent of x looks like. We have graphed the general equation of y equals tangent of bx. This is example 3. And we use the specific formula of y equals tangent of 2x. And here we have to find out where our asymptotes are going to be, because we know that our asymptotes are with this. If b was 1, our asymptotes would be at negative pi over 2 and pi over 2. And so what we did is we set 2x, bx, 2x equals negative pi over 2. We divided both sides by 2, and we got x equals negative pi over 4. And we said bx equals pi over 2, divided both sides by 2, and got x equals pi over 4. So we drew our asymptotes at negative pi over 4 and pi over 4. And then we drew our curves. And remember that our 0 point is going to be halfway between our asymptotes, and we have to hit our amplitude point, and we have to mark that halfway between our asymptotes and the zeros. And then we looked at y equals 3 tangent of bx, or a tangent of bx. We used the specific formula of y equals -3 tangent 1/2 x. So we did 1/2 x equals negative pi over 2. We multiplied everything by 2. We got x equals negative pi. And we used 1/2 x equals pi over 2. Multiplied everything by 2. We got x equals pi. So then we drew our asymptotes. We had our 0 point. And then we had to plot our amplitude points at halfway between our 0 and our asymptotes. And because it's negative, that flipped it around and made it look like a cotangent curve. And then we looked at the last problem that we did, which was example 5. And we looked at y equals a cotangent of bx. That was our general equation. And our specific equation was y equals 1/2 cotangent of 2x. And what we realized was that instead of negative pi over 2 and pi over 2, we had to use 0 and pi for where our cotangent hit, because that's where our 0 points are. So we said 2x equals 0, because bx is right there. And we divided by 2, we got x equals 0. We said 2x equals pi. We divided by 2, and we got x equals pi over 2. So at 0 and pi over 2, we drew our asymptotes. And because it's cotangent, we knew the shape. We knew our 0 was going to be halfway between our asymptotes. And then halfway between the 0 and the asymptotes, we knew we were going to have is where we had to have our amplitude. And our amplitude in this problem was 1/2. So we put a point at 1/2 and we drew our curve, our cotangent curve here. So what I want you to do with the rest of the class period is your assignment is page 165, 21 to 32. And again, you're going to work at least 2 problems for y equals tangent of bx, at least 2 problems for y equals a tangent of bx, and at least 2 problems for y equals a cotangent of bx. So there's going to be a minimum of 6 problems you have to do. You get to pick what they are, but you do have to work a minimum of 6 problems. There's more there if you need it.